All right, we're going to begin chapter 5. Now, when you take a probability and statistics course, you study two things, probability and statistics. And now, the two fields are related, but they are different. Okay, so like we'll talk about standard deviation, the mean, and histograms and things like that. Okay, but it'll be in the context of probability though. So probability describes how likely it is some event will happen. If we look at the proportion of times an event has occurred over a long period of time or over a large number of trials, we can be more certain of the likelihood of its occurrence. In probability, an experiment is any process with uncertain results that can be repeated. One of the things that we care about is called a sample space, and the sample space, which I'm going to let the symbol capital S represent sample space, of a probability experiment is the set of all possible outcomes. Okay, so we'll determine the sample space for each experiment. So problem one, we roll a single die. So what can happen when you roll a die? Well, you can get either 1 or 2 or 3 or 4 or 5 or 6, right? And now there's a key word here in the definition that can very easily be overlooked, and that's the word set. Okay, the sample space is a set. So when I write out the sample space, I need to make sure I'm using set bracket notation to do that. Okay. Problem 2, answer a true/false question. Okay, so I set up my set brackets, and the answer is either true or it's false, right? Problem 3. Flip a coin once and let H denote heads and T denote tails. Okay, so I set up my set brackets, and the coin is either going to be heads or tails. Okay, H or T. What if I flip a coin twice? What are the outcomes there? Well, you can get heads, or a heads first or a tails second, or a tails first and then a head second, or both flips could be tails. Okay, and then close up the set. What if I flip a coin 3 times? Okay, what are the results? Using set brackets, so all 3 flips could be heads, or you get 1 tails. Now the 1 tails can come either first, second, or third, so I'd list 3 elements there. Go tails, heads, 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 tails, heads, or heads, heads, tails. Or I get 2 tails and 1 heads. The 1 heads can come either first, second, or third. Okay, so I got 3 more elements to list. It'd be heads, tails, 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 heads, tails, or tails, tails, heads. Or, of course, the last outcome could be when all 3 flips are tails. Okay, so there's 8 elements for when I flip a coin 3 times. An event is any subset or portion of the sample space. Okay, a subset is a set, by the way. So I just like with a sample space, I need to use set bracket notation whenever I list an event. And a subset is a portion of a set. Okay, events events are denoted by using capital letters such as event E. Okay, and so let's take a look at problem 6. Roll a single die and let event E be the event that you roll an even number. Okay, so in this set, so what are all the even numbers? When I roll a die, it'd be 2, 4, and 6. Okay, and notice how this event is a subset of this set. So all 3 of these elements can be fit in what is the bigger set. Okay, that's what I mean by a subset. Number 7, select a month and let event A be the event that the month begins with the letter J. Okay, so set A would consist of all the months that begin with the letter J, so it'd be January, June, and July, 3 months. Use commas to separate the elements from that are in the set that you're listing there. Okay. Problem 8, roll a pair of ordinary dice and assume that the dice are easily distinguishable. Maybe let one of them be red and the other one be green. Okay, and in the ordered pair little r, little g, little r will represent the number showing on the red die, and little g will represent the number showing on the green die. Okay, so that way I can keep the order straight. Part A, determine the sample space. Okay, so what are all the ways that can happen when I roll a pair of dice? So I'm using ordered pair notation. Okay, ordered pair means order is important. Okay, and I'm also using set bracket notation. Okay, so in the sample space here, 1, 1 means that each of the two dice came up with the number 1. Okay, why don't we list all the ways for when we see a 1 showing first? Okay, so I can see a 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And then list all the ways for when you see a 2 showing on the first die. So it'll be a 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And then a 3 showing on the first die. So it'll be a 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Okay. And then a 4 showing on the first die. And then a 5 showing on the first die. And then a 6 showing on the first die. Okay, so if you see a 6 showing on the first die, you can roll a 1 on the second die, or a 2, or a 3, or a 4, or 5, or 6 on the second die. Okay, so how many elements did I list total in this set? Well, it'll be 36 elements total. So 6 rows by 6 columns. 6 times 6 is 36. Okay. Part B, let event A be the event that you roll a 9. Okay, right? Event A is a set. Okay, and by the way, an event is a set. Okay, so it's important that whenever we list an event, we're using set bracket notation. Okay, so what are all the ways that can happen when I roll a 9? Well, I can roll a 3 and a 6, a 4 and a 5 and a 4, or a 6 and a 3, and that'd be it. Okay, I sometimes see students write like, 1 and 8, 2 and 7. No. So you've only got a 6-sided die, right? So you're not gonna have a 1 and an 8, or a 2 and a 7 or something. It's 7 and 8 are not available to us. Part C, let event B be the event that you roll an 8, right? B is a set. Okay, so what are all the ways that you can roll an 8 with 2 dice? So you set up our set, and we're using ordered pair notation. So a 2 and a 6, a 3 and a 5, a pair of 4s. And now, if I were to write a 4 and a 4 again, is that okay? Is that okay, or should I not do that? Well, yeah. So one nice thing about set bracket notation is that you can list an element as many times as you want. You're only going to count that as one that is different from the others. So like if I want to list 4, 4, 23 times, I could do that. Okay, why I would do that, I don't know. But I would still only count that as one that is different from the others. Okay, so now if I see a 4 on the red die and a 4 on the green die, that's not any different from if I switch the two 4s, right? I still have a 4 on the red die and a 4 on the green die. So to me, it doesn't make sense to list this element again. You've already counted that, right? Now, switching these other values will make a difference. So if I see a 5 on the red die and a 3 on the green die, or a 6 on the red die and a 2 on the green die, okay, then close up the set. By the way, one thing that I want you to see here is that notice how there's more ways to roll an 8 than a 9. Okay, so and I haven't done anything with probability yet. Okay, the terms sample space and event, those are just kind of preliminary terms for when we calculate a probability. And by the way, notice that these are subsets of the sample space. So all of these elements can be seen in what will be the bigger set. That's what I mean by the term subset. Okay, so part D, Let event C be the event that's given here. Describe event C in your own words. Okay, so let's see. If I describe this in my own words, it looks like I have a 1 showing on the dice. Only one die is showing a 1 though, right? So I don't see the ordered pair 1 1 listed. So I'd want to make sure to say that. So exactly 1 of the dice comes up with a 1 or shows a 1 or something like that. Okay. All right. So now I mentioned that the terms sample space and event, those are just kind of preliminary terms for talking about probability. Like I haven't said anything about probability yet, although I'm going to do that now. Okay. An experiment has equally likely outcomes when each outcome has the same chance of occurring. Okay, so you're not being biased towards selecting, one element over another element. So every single element has a fair shot at being selected. Okay, then if A is an event, then the probability that A occurs, denoted by this symbol right here, the probability of A, if all the outcomes in the sample space are equally likely, then the probability of A is defined as the probability of A equals the number of outcomes in set A divided by the number of outcomes in the sample space. Okay, a couple of things here. First of all, equally likely is a phrase that we sometimes see in probability. That just means equal. Okay, so you're not being biased towards selecting one element over another element or one group of elements over another group. Okay, any element or group of elements has a fair chance of being selected. Okay. The probability of A, that's common notation for when we write out, a probability calculation. Always include the probability sign whenever you compute a probability. So that's something I tell my students. Don't just write P equals. Okay. So the reason is because later on. In chapter 5 here, you guys are getting just kind of a dose of a basic probability, okay? And we're going to continue to talk about probability throughout the rest of the semester. And if you just write P equals and then the answer, that's wrong. That's actually bad notation because in chapter 6 we see a symbol called little p. Okay, and so it can be confusing. What do we mean by that? So always include the event next to the probability sign. Probability of A, if you're calling the event A. Now sometimes we got to write out the event in words, okay? And actually we'll be doing that quite a bit here. But you just write out in words whatever the event is, okay? Fractions or decimals are fine with me, okay? Make sure that you're using correct notation and following the directions on my math lab for how they want the answer, okay? Probability rules, there's 2 rules for probability, okay? So if A is an event, then the probability of A is greater than or equal to 0, but less than or equal to 1. So in other words, probability can't be negative. That doesn't make any sense. Okay, and probability can't be bigger than 1. That also doesn't make any sense. Okay, and if you think about this, like in terms of a percent chance of something happening, you can't have a negative percent chance of something happening. You can't also have a over 100% chance of something occurring. Okay, so what we're doing is we're converting those percentages over to decimals or fractions, and the decimals or fractions always have to be between 0 and 1. Okay, you can have a probability of 1. Okay, that means that there's a 100% chance of something occurring, or you can have a probability of 0. Okay, that means that there's a 0% chance of something occurring. Okay, you can't ever be outside of those boundaries though. The second rule with probability says that the sum of the probabilities of all the outcomes must equal 1. Okay, that is, if the sample space consists of n outcomes, e sub 1, e sub 2, all the way up to e sub n. I'm just representing those as outcomes. Then the probability of E sub 1 plus the probability of E sub 2 plus the probability of E sub 3 plus all the way up to the probability of E sub n. That's equal to the probability of the sample space, which is always equal to 1. Okay? So we'll see these two probability rules in every single probability question. Okay? And if one of these two rules hasn't been satisfied, then you've miscalculated. Okay? And you got to go back and see what the error is. So let's take a look at problem 9, where it says a local golf store sells a bag that contains 80 golf balls in it. Suppose that the bag contains 35 Titleists, 25 max flies, and 20 top flights. Okay, part A, what is the probability that a randomly selected golf ball is a Titleist? Okay, so I write the probability of the event Titleist, and the way I define probability is I need the number of things in the event divided by the number of things in the sample space. There's 80 golf balls total in the bag. So 80 is going to go in the denominator. And of the 80, 35 of those are Titleist brand golf balls. Okay, so 35 divided by 80 in decimal form would be 0.4375 exactly. Okay, and so the interpretation here would be to say that I would have a 43.75% chance of randomly selecting a ball that is a Titleist brand golf ball. Okay. 35 divided by 80, by the way, is 7 divided by 30, or 7 divided by 16. So if I were to use fractions or decimals, of course, make sure that you read the directions there. Part B, what is the probability that a randomly selected golf ball is a max fly brand ball? Okay, so the probability of max fly equals, there's 80 balls in the bag, 25 of them are max fly brand golf balls, so 25 divided by 80 reduces to be 5 over 16, and 5 over 16 in decimal form is exactly 0.3125. Okay, so there's a 31.25% chance that I would select a max fly from the bag, okay, if it were a random thing. Part C, what is the probability that a randomly selected golf ball is a top flight brand ball? Okay, well, so the probability of top flight, there's 80 balls in the bag, 20 of them are top flight brand. Okay, 20 divided by 80 reduces to 1/4 or 0.25 from using decimals. And so there's a 25% chance of selecting a top flight from the bag. Okay. Notice that the two probability rules are satisfied in problem 9. Okay. So let's take a look at these again. So every single event has a probability that is between 0 and 1, or that's what I see here. Okay, so that's rule 1. Now rule 2 says that the sum of the probabilities of the outcomes must equal 1. So I've found the probability of every single outcome in the sample space, right? There's only Titleist, max flight, and top flight golf balls in the bag, right? So now what I'm saying is if I add up these fractions here, I should get 1 exactly. Okay, and I've got my common denominator of 80. 35 plus 25 is 60, plus 20 is 80. 80 over 80 is 1. Okay, that always needs to happen whenever you do anything at all with probability stuff. Okay, these two rules always need to happen. Okay, why don't we go ahead and stop the video right here in the notes, and I'll pick up with problem 10 in the next one then.